So today we'll continue with the next topic of the unit first of the data communication and computer network, which is introductory concept. In the last class we have discussed almost our full unit, and last two topics are left over. We'll discuss in this slide, right? So today's topic is like digital modulation. We are going to discuss. So let's understand what is digital modulation. Digital to analog signal conversion techniques are called as digital modulation technique. So conversion of digital to the analog signal is the digital modulation. Digital modulation provides more information capacity, higher data security, quicker system availability with great quality communication. Hence, digital modulation techniques have a greater demand for their capacity to convey large amounts of data than analog modulation techniques. So there are many types of digital modulation technique and also their combination depending upon the need. So first is the ASK, FSK and the PSK. ASK amplitude shift key, frequency shift key, and PSK is phase shift key. We will discuss them one by one. The amplitude of the resultant output depend upon the input data, whether it should be a zero level or the variation of the positive and negative depending upon the carrier frequency. So in the amplitude shift case, generally we change the amplitude of the carrier wave which carries the signal. Right? In the FSK, the name itself suggests the frequency of the output signal is changed according to the input signal. The frequency of the output signal will be either high or low depending upon the input data applied. Next is phase shift key. The phase of the output signals get shifted depending upon the input. There are mainly of two types, namely binary phase shift key BPSK and quadrature phase shift key QPSK according to the number of phase shift. The other one is differential phase shift key DPSK, which changes the phase according to the previous value. Right, so here the phase of the carrier wave is changed. Like we can see it over here in the diagram. This is like our digital signal and this is the carrier wave. So in the amplitude shift key we have changed the amplitude of the wave, like you can feel the difference in the both. Right, for the zero, then for the frequency, in the frequency phase, like for the one, whenever the one is encountered, like here we have zero, so only the one wave we have. Then for the one we have the more number of waves, so in the frequency we have more number of waves. So next in the phase shift key we change the phase of the wave. So whenever data change from 0 to 1 or 1 to 0, phase shift of pi takes place. So here 0 to 1, so here a phase shift of pi has been taken. Next for 1 has encountered, so no phase shift. Again 0 encounter, a phase shift of pi will take place. So these were the three kind of modulation techniques which we can easily represent with the help of the graph. Next is the media and digital transmission, like how is data being transmitted. So we'll discuss them here one by one. In the data communication terminology, a transmission media is a physical path between the transmitter and the receiver, that is the channel through which the data sent from one place to the another. Like how is data being transmitted from the sender to the receiver. Transmission media is broadly classified into the following types. First is guided media. It is also referred to as a wired or bounded transmission media. Signals being transmitted are directed and confined to a narrow pathway by using physical links, right? So there are the three types of guided media. First is twisted pair cable. It consists of two separately insulated conductor wires bound about each other. Generally, several such pairs are bundled together in a protective shield They are the most widely used transmission media. Twisted pair cable are of the two types. So twisted pair, like we have two wires and those are bounded over one another. Unshielded twisted pair UTP. This type of cable has the ability to block interference and does not depend on a physical shield. Of this purpose, it is used for telephonic applications. Its advantages are least expensive, easy to install, high speed capacity. A disadvantage, susceptible to external interference, lower capacity performance in comparison to STP, shorter distance transmission due to the attenuation. Next is shield. Next is shielded twisted pair STP. This type of cable consists of a special jacket to block external interference. It is used in fast data rate, Ethernet, and in voice and other channel of telephone lines. Advantages: better performance. At its advantages are better performance at higher data rate in comparison to UTP, eliminates crosstalk, comparatively faster. Disadvantage: comparatively difficult to install and manufacture, more expensive and bulky. Next is coaxial cable. It has an outer plastic covering containing two parallel conductors, each having a separate insulated protected cover. Right? Coaxial cable transmit information in two mode: baseband mode, dedicated cable bandwidth, or broadband mode. Cable bandwidth is split into separate range. Cables, TVs, and analog television network widely use coaxial cables. What are its advantages? High bandwidth, better noise immunity, easy to install and expand, inexpensive. Disadvantage: single cable failure can disrupt the entire network. So, if a cable failure occurs, it will destroy the whole network. Next is the optical fiber cable. The use of the concept of reflection of light, total internal reflection, which we call TIR, is used by optical fiber. Reflection of light through a core made up of glass or plastic. The core is surrounded by a less dense glass or plastic covering called the cladding. It is used for transmission of large volume of the data. Advantages: increased capacity and bandwidth, lightweight, less signal attenuation, immunity to electromagnetic interference, resistance to corrosive material. Disadvantage: difficult to install and maintain, high cost, fragile, unidirectional, that is, will not need another fiber if we need bidirectional communications. So these are the disadvantages and advantages of the optical fiber. Next is the unguided media. It also refers to as wireless or unwounded transmission media. No physical medium is required. Like in the guided medium, we need a cable for the transmission. Like here, with the help of the air, the data is being transmitted. No physical medium is required for the transmission of the electromagnetic signals. What are its features? Signal is broadcasted through air, less secure, used for larger distance. There are three major types of unguided media. First is the radio waves, second microwaves, and third is the infrared. Radio waves, these are easy to generate and can penetrate through the buildings. The sending and receiving antennas need not to align. Frequency range from 3 kHz to 1 kHz. AM and FM radios and cordless phones are radio waves. In the terrestrial, radio waves can be further transmitted in the terrestrial and the satellite. In the terrestrial form, like the two antennas are being placed, and on the antennas the dish are placed through which the data is being transmitted. While in the case of satellite is being with the help of the satellite, the data is being transmitted. Microwaves, it is a line of sight transmission. The sending and receiver antenna needs to be properly aligned with each other. The distance covered by the signal is directly proportional to the height of the antenna. Frequency range 1 GHz to 300 GHz. These are majorly used for the mobile phones communication and television distribution. And the last is the infrared. Infrared you might have seen in the home also. Infrared waves are used for very short distance communication, they cannot penetrate through the obstacles. This prevents interference between system. Frequency range 300 GHz to 400 terahertz. It is used in TV remotes, like as I told you, you must have seen them in your home. Wireless mouses, keyboards, printer, etc. Right, so this was all about the radio wave, microwave and infrared, and the unit 1 has been completed in this video. Thank you so much. In the next video we will continue with the next unit. Thank you.